All right, so let's start with the new topic that is Amazon SQS. So Amazon SQS. So here SQS stands for Simple Queue Services. Okay. So what does Amazon SQS does and why we should actually use it, right? So Amazon SQS is just like a to-do list for the different part of your system. It actually helps the different components to talk to each other by passing messages, right? So even if they are not ready at the same time, we can pass the messages, right? So Amazon SQS is a fully managed messaging query service that actually allows you to decouple and scale microservices, distributed system, and serverless application. It actually ensures the reliability and scalability along with the communication between the component of the system. Right now, before we proceed forward with the key features, let actually understand how does it works at the back end, right? So basically, imagine one part of your app which actually writes a message on a whiteboard, okay, and another app which comes by later will pick up that message and process it. Meaning, these are the different parts of your application which are working independently at your own pace. But the only thing that we'd be needing is like the application that you are writing an application message on your whiteboard, and second, that message to be picked up later by the another application which might be in progress, right? Here, the parts of your application doesn't have to wait for each other. One can send a message and other can pick it up whenever it is ready. And third thing would be like the message stays into the queue until it is picked. So some if sometimes go wrong, the message won't be posted. So right, that was the basic use case you can say, and the basic functionality. How does a simple queue services work at the backend, right? So now let us cover the key features. The first is messaging queue. So SQS allows you to send, store, and receive messages between the software components without needing them to interact directly, as we covered in the working structure, right? The components can communicate asynchronously, improving the fault tolerance and scalability. Now, when I mentioned that when the application second part is not ready, it will keep the message in queue, and once it is ready, it will send the message, right? So the same way this messaging queue thing works. Now, let us understand the types of queue. So in SQS, we have two sort of queues. First is standard queue, and second is FIFO queue. FIFO stands for first in, first out. So standard queue, here the messages are stored and actually it is delivered once, but sometimes might be delivered more than once, and the order might not be the exact. But when it comes to FIFO, the messages are delivered exactly once in the exact order they were sent, right? So here you have unlimited throughput in standard queue and at least once delivery, meaning one delivery can be compulsory. You can say that one message will be delivered for sure, and sometimes more messages can be delivered. And third is best effort for ordering. So basically, they try to give you the ordering, but it is not guaranteed that they arrive on the same order, right? But when it comes to FIFO, it is also known as exactly one processing where no duplicates will be found, and here the sequencing that they are following is first in first out message delivery system, right? All right, so let us understand about the scalability. So SQS actually can handle millions of requests per second. You can scale them seamlessly as your application grows. Okay. Decoupling, so decouples, it actually helps the component of a distributed system, allowing each part to operate independently at its own pace, right? Now, durability, so messages are stored redundantly across AZs to ensure the reliability. And when it comes to visibility timeout, so it actually allows you to temporarily hide messages from the other consumers when it is being processed, preventing multiple consumers from processing the messages at the same time simultaneously. The important part that we need to note over here is that letter queues, which are also known as DLQs. So when the message cannot be processed due to some reason, after a certain number of tries, they can be moved to a dead letter queue for further analysis. And here the message retention technique is also been offered, where the queue is for queue can be standing for 1 minute to 14 days, with the default retention period of 4 days. Now, when it comes to SQS, the SQS, so the main thing that we can observe here is about the integration. So the integration part such as that it can be seamlessly integrated with AWS services such as AWS Lambda, EC2, SNS, and RDS. Okay, so few of them we are going to cover in the following one. So this was all about SNS, and let us now understand the use cases where actually we can use the SNS, right? So the first would be the decoupling microservices. So SQS can help you with the decouple application components, just like a front end of a website and a back end of a back end service of a website, right? So basically, it can ensure the front end doesn't get slowed down even if there is a break and there is a downtime in back end services, or even sometimes there might be a possibility where the back end is been overloaded. At that time, it will help us with that specific thing because we are using decoupling microservices. Now, when it comes to batch processing, you can actually queue up large number of workloads such as data processing and can process them asynchronously without affecting the real-time operations. Why? Because the messages here can store for a time, and unless and until that next thing has been ready, it will store, and once it is ready, it will send the message. Right? Now, task queue. So you can manage the task distribution amongst multiple nodes, improving the system fault tolerance and scalability. Now, when it comes to message buffering, it will actually help you to smooth out the traffic. Specifically, when I say traffic, we are talking about the traffic spikes that we get. Okay, and basically those requests are ensured by the application as you process them, and that is possible. Why? Because we are using message buffering. Now let us understand few of the key concepts behind SNS. The first key concept here is loose coupling. So SNS enables loose coupling between the microservices, which actually makes them more scalable and easier to manage. Second is error handling. So here we are using one technique known as dead letter queue technique, or you can also say them dead handling. So basically, these dead letter queues are actually used to manage the messages that cannot be processed further successfully, which actually helps us to ensure that the errors are isolated and it don't cause error failures anywhere. Idempotency. So idempotency meaning we are not repeating something, right? So it actually ensures your application are idempotent, meaning they can handle the same message being delivered more than once. Okay. And when it comes to cost efficiency, you can actually pay for the number of messages sent and received, and SQS is highly cost optimized based on the large scale distribution applications. So yeah, let us summarize the entire thing in a nutshell. So SQS is an essential service for decoupling and scaling distributed system, which actually makes the system easier to build reliable, scalable, and fault-tolerant application. It actually offers both standard and FIFO queues to cater the difference between the use cases, which actually helps us to ensure in the handling of large volume of messages, right? So yeah, that was all about SQS. SQS helps the different parts of application to communicate smoothly and efficiently, even if they don't operate at the same time. So yeah, that was all about SQS, and see you in the next one.